Hello, so today we are gonna present our final group project of microcontroller and application classes. So we will be presenting what our project does, which is a fire alarm notification system. Uh, okay, so in this project, we will be constructing a comprehensive fire alarm notification system using the Arduino platform within the Tinkercad. It look like this. So our system will include several key components such as a resistor, a fire detector, an alarm, an LED, an Arduino board, and a breadboard. So each component will play a crucial role in detecting the presence of fire and alerting the user through visual and audible signals. The reason why I didn't talk about the LCD board because when we bought it from the store, the wire that we have that's not compatible with the LCD, so we will not be using this one. But the code have the thing that if you have a compatible one, it's supposed to work normally. Yeah. So first we will be integrating a fire detector which serves as a primary sensor for detecting smoke or high temperature. This sensor will be connected to the Arduino Uno board, which acts as the brain of the system. So the Uno will process the signal received from the fire detector and determine whether they indicate a potential fire hazard or smoke in the building or not. So the resistor will be used to manage current flow and protect the component from damage due to excessive current. A proper resistor value will ensure that the fire detector and other components receive the appropriate voltage levels. And so next is the alarm component, right? Alarm component, typically a buzzer, will emit a sound, a loud sound when the fire detector or smoke detector signals the presence of the smoke, providing an audible alert to nearby people. An LED also will be incorporated to our system. So, for example, a red LED might light up when the smoke has been detected, while a green LED could indicate that everything is normal and the system is working normally. This LED provides an visual status of our system and the building. We will also be using the text module, at least that's what we plan, such as an LCD screen to show detailed notification, whether it's fire detected, smoke detected, evacuate, or everything is normal, no fire detected, to the people in the building to ensure their safety and the safety, yeah. The breadboard will also facilitate the connection of all these components, allowing us to create a prototype without soldering using jumper wires. We will be connecting the fire detector, alarm, LED resistor, and support text display module to our Arduino Uno board. Throughout the project, we will program the Arduino using mostly the Arduino IDE. So writing a code that reads data from the fire detector, process it, and controls the alarm and LED accordingly. This will involve setting up the pin mode, getting analog or digital input, and using conditional statement to determine the system response. Mostly this conditional works with an LCD and or LED. By the end of the project, we will have a fully functional fire alarm notification system capable of detecting potential fires and alerting users through multiple channels, ensuring timely and effective warning in the event of an emergency. This system will be a valuable tool for enhancing safety and preparedness in any environment or in any building. For the next session, I will be talking about what we need to create the system that we want and what we need to buy in order to make this project possible for our final project. So the first thing that we need to buy is the gas sensor. So the microcontroller does not give us these pieces of equipment, so we need to buy it off from the internet. Okay, so next is the Arduino Uno R3, as you can see here. Uh, the lab actually provide this for us, so there's no need to buy one. And LCD 16, basically this one, the tech displayer. We did bought from the online, but it's not compatible with the wires from the lab, so we will be skipping that one. So next is the PSO. The PSO is actually just our alarm system. So we we have this one. Uh, we did bought the PSO, but it also doesn't work just like LCD. So we just use what we have. This is what alarm we have. Yeah. Next is a LED, a green and a red one. This one the lab also have. So that's nice. The resistors 1K and 4.7K resistor. For the resistors, we did bought some of the resistors, such as the 4.7. Uh, but some resistor the lab does provide for us. Okay, so I think that's it. That's what we need to build our system aside from the wires.
Next is circuit diagram. Here is the circuit diagram of our fire alarm system. Let's break down each component and its connections. First is Arduino Uno. The Arduino Uno is the central microcontroller. It manages all the input and output of the system. Next is LCD display. The LCD display shows that message. Data pin DB4 to DB7 are connected to the Arduino digital pins for data transfer. Control pins RS, RW, and E are connected to the Arduino to manage the display. Power is supplied via VCC and GND pin. Both LED control the backlight. Next is gas sensor. Gas sensor detects gas levels. Connect to the analog pin A0 on the Arduino. Output an analog signal proportional to the gas concentration. Next is LED. System use 3 true LED for visual indication. Red LED connect to the digital pin D2 via a 120 ohm resistor, indicating an alert condition. Green LED connect to digital pin D1 via a 220 ohm resistor, indicating a safe condition. Next is buzzer. The buzzer provides an audible alert. Connect to a digital pin on the Arduino. It sounds when gas levels are high. Next is resistor. Resistors are used to limit current and protect components. R1 1 kilo ohm resistors connect to the buzzer. R2 4.7 kilo ohm resistor connect to the gas sensor. R3 and R4 220 ohm resistor for the LED. R5 1 kilo ohm resistor connect to the LCD. Next, let's move on into the code that powers our fire alarm system. Code is written in Arduino C base language. Libraries and initialization. The liquid crystal library controls the LCD display. The LCD object is initialized with the corresponding pins. In definition and threshold, defines pin for the red LED, green LED, buzzer, and gas sensor. while sensor set the threshold value for triggering the alert. Setup function. Configure spin mode and initialize serial communication and the LCD. Do function. Continuously monitors the gas sensor, controls LED buzzer and LCD based on sensor readings. Now let's walk through the step-by-step operation of the fire alarm system. First is monitoring. The gas sensor continuously monitors the environment for gas level. Reading. The analog value from the gas sensor is read by the Arduino and pins to the serial monitor for debugging. Third is condition check. The Arduino compare the sensor value to the predefined threshold. Fourth is alert condition. If the gas level exceeds the threshold, the red LED is turned on, indicate danger. Green LED is turned off, also sounds an audible alarm. LCD displays alert for 1 second, and then evacuate for 1 second, alternating to ensure visibility. Fifth is safe condition. If the gas level is below the threshold, green LED is turned on to indicate safety. Red LED is turned off. Buzzer is silent. LCD display safe for 1 second, and then all clear for 1 second, alternating to reassure users. Now let's see the system in action.